Hi all, welcome to Kothayat channel. In this video, we are going to develop a machine learning model to predict the Bitcoin future prices based upon the past price movements. Bitcoin is one of the cryptocurrencies trending in the current market. Last month, we have uploaded a video in our channel to predict the stock market future prices with the machine learning model. We really got a very good response on that video and we are really thankful for that. Lot of people asking questions about how to predict the future stock prices once the model is developed. In this video, I'm going to cover that. And you can use this very same model to predict the stock prices also. But you can train your model with the stock you want to predict the future price for better results. And I want to put out a disclaimer here. This is not an investing advice. I'm not a professional who is qualified in giving any financial advice. This video is purely about programming using financial data for educational purpose. Again, I'm saying this is just for the educational purpose. Let's dive into the demo. Here is the final web application looks like Bitcoin price prediction model. Okay, here is the data, Bitcoin base price data which we have downloaded from the Yahoo Finance from 2015 January 1st to almost November 29th, right? Yeah, till November 29th we have taken the data from the Yahoo Finance. Okay, now the next thing is a Bitcoin line chart. This line chart has been drawn based upon the data which is showing in the above here, right? So based upon this data we have drawn a line chart here. And the next thing is our model had predicted the last 100 days Bitcoin prices, and we are comparing that predicted prices with the original prices of the Bitcoin. Okay, here is the predicted price and versus the original price, and if you see here there is a slight discrepancies here and there. Okay, and finally here is the chart for the above data predicted versus the original prices chart for the last 100 days data. And here is the most important part, predicted the future days Bitcoin price. So here we have predicted the next 5 days from, we have the data till November 29th, right? So next 5 days mean the sense November 30th to December 4th. So whatever the Bitcoin price is going to be, so we have predicted that price, okay, by using this machine learning model that we have developed here. This is what the final project looks like. This is what we are going to build in this video. First things first, let's discuss about programming machine learning model to predict the future prices of the Bitcoin. First, we would need the data. So we would need the price history of the Bitcoin to get started. So once we have the data, the next step is EDA, exploratory data analysis. Here we are going to explore the data and we are going to analyze the data, how we are going to use it. And third step is creating a model. So here we are going to create a sequential model with the Keras layers such as LSTM, dense and dropout. So once our model is created, we are going to train our model with the training data set. And once the training part is completed, we are going to test our model with the test data set. And here we are going to compare the predicted prices with the test data set versus the original prices. So once we are satisfied with these results, we are finally predicting the future prices of the Bitcoin by using the machine learning model. Requirements to get started with the development of this project. The first Python library which we would need is Finance to download the Bitcoin price history data from the Yahoo Finance. And second one is matplotlib. This is the library which will be used to draw the charts. And third one is scikit-learn. As part of the pre-processing, we are going to scale the data. For that one, we are going to use the scikit-learn. And fourth one, we would need the Keras for the layers and models. And fifth one is NumPy and pandas for data handling and analysis. And finally, Streamlit to deploy this entire model as a web application. Let's start with the coding. Here I have created a project folder called Bitcoin, and here I'm going to open Jupyter Lab. Okay, here we are going to install the necessary Python libraries. Okay, here we would need pip install is the command to install the Python libraries. Finance, NumPy, pandas, scikit-learn, matplotlib, Keras and Streamlit, and just press enter. These Python libraries will get installed in your system. All these libraries are already installed in my system, so I'm not going to install them now. So once we are done with the installing of the Python libraries, we are going to create a new Python notebook. I'm going to rename it as Bitcoin ML model. First step, let's import the necessary Python libraries. Import Finance, SYF, import pandas as pd, import numpy as np, import matplotlib.pyplot as plot. Okay, just imported them. Now let's download the Bitcoin prices. Okay, data is equals to byf dot download and btc-usd. This is the stock symbol for the Bitcoin, and starting date is going to be 2015 January 1st to 2023 November 30th. Okay, so we got the data. Let's convert this data into pandas data frame. Okay, pd dot data frame of data. Now we got the data. So here is the total data. We have date column as an index column, and the next one is open. This is the opening price of the Bitcoin on that particular day, and the second one is the high. What is the highest price on that particular day, and the lowest price of the Bitcoin on that particular day, and finally here is the closing price of the Bitcoin on that particular very day, and adjacent close, which is similar to the close, and the value number of Bitcoins has been transaction happened on that very day. So here we actually need the close, we don't need rest of the columns actually. So we are going to concentrate mostly on the closing price of the Bitcoin. Okay, first let me reset this index first. Data dot reset index, and in place is equals to I'm going to reset that index, and let's set the data. So here is the data, date column, open, high, low, close, adjacent, close, and value. So I just said we did only close, right? So let's drop the rest of the columns. Drop columns is equals to date and open and high and low and adjacent, close, and value. Okay, comma, in place is equals to true. Now let's check the data. So here is the data. So now we have 3255 rows of data is there. Okay, and we are going to split the data into test data set and training data set. Okay, and what I'm going to do is data, let it be, and okay, test data, sorry, training data first. Training data will be except the last 100 days. I want to put entire data set into the training data set. Okay, because if you see here, let me do one thing. Plot dot figure of fixed size is equals to 8,10. Okay, plot of data, plot dot show. If you see here, this is the Bitcoin prices from 2015 to 2023 of November. Okay, let me just zoom out here at content, right? Okay, if you see here, the price here is first reached 20,000 quickly, and then it again dropped to less than 10,000, and again here somewhat consolidated. Again it reached all of a sudden to more than $60,000 of USD, and again it came back to around 30,000, and again it reduced, again it went on to $70,000, and again it came back to around $20,000, and now it is around $40,000. Okay, if you see here, this cryptocurrency Bitcoin is very fluctuating in the prices. So that's the reason what I'm going to do here is we are going to take the most of the data into the part of the training data set, so that our model can identify the data patterns with the time series. Here what I'm going to do is I'm going to take the most of the data is part of the training data set, because I just want the model to understand this price fluctuations to make it as a more accurate one, and testing data set will be very less. Okay, and we have here, let's Okay, here we have 3255 rows, right? So I will just take only 100 rows as the test data set and remaining 3155 rows as a training data set. Okay, let's do that split up. Okay, train and score data is equals to data of minus 100. Okay, and test data is equals to data of, guess this is wrong. Okay, let's check it out. Our answer is no. Okay, let's check the shapes. Train and score data dot shape. So we have 3155 as a training data set and test data should be 100, right? So once we have done the split up, then we have to do the scaling of this data. Okay, what we are going to do is from sklearn dot preprocessing input min max scalar. Okay, and scalar is equals to min max scalar, and here feature range is equals to 0 comma 1. I want the prices to be scaled between 0 and 1 with the scalar approach. Okay, let's scale the training data. Train data scale is equals to scalar dot fit and score transform of this train data. So we have done the scaling of this data set. Okay, now I'm just going to explain one of the information. So to predict the future price of the stock market or a Bitcoin prices, we would need the past history, right? How many days of past history we would need? Let's take an example. 1 2 3 4 5 6 7 8 7 8 9 and 10. Okay, if I want to predict the 11th day price of the Bitcoin, I would need the consideration of at least the 10 days. Okay, if I take the price of the last 10 days, then I'm going to predict the 11th day. Suppose if I am going to predict the 12th day price of the Bitcoin, then I would need the data from the second day to 11th day, the last 10 days data. Okay, based upon this data only we are going to predict the, we are take the consideration of last n days, n number of days to get the n plus 1th day. Okay, so here we can say that base days. Okay, what are number of days that we need to consider to predict the next day stock price? I'm going to make it as 100. Okay, that would give us the realistic day. Okay, okay, I'm just creating it as a base days as 100. Okay, here I'm going to split the, do the array analysis. Okay, here what I'm going to do is slicing of the array. Okay, I will store the last 100 days of the data set into one part of the array, and the next dimension would be the price. Okay, that is what we are going to do, the array slicing. Here x is equals to y, and I'm taking two arrays here. Okay, and so take the two arrays for I in range of, okay, base days, comma, that is 100 days, comma, train data scale dot shape of 0. Okay, it will repeat for the entire array. Next, x dot append, what we are going to do is train data scale of I minus base days to I. Okay, and y dot append as train data scale I comma 0. Okay, so we have done the array slicing. Let me take off x of 0. Okay, I'll show you. If you see here, the last 100, okay, 1 to 100, the days of 1 to 100 stock price have been stored here like this. Okay, and based upon this 100 days of data, we are going to predict the 101th day data. Okay, and if I go for x1, it will be having from the day 2 to 101th day. Okay, to predict the 102nd day. So that is how we have done the array slicing here. Okay, and if you see here, why the actual price will be stored for that particular day. Okay, and this data is scaled, so that's the reason you are not able to see the exact numbers here, because we have done the scaling here, right? So we have done the scaling of the data. Okay, and array slicing as well. Now x comma y is equals to, we have to convert this arrays to numpy arrays. Okay, np dot array of x and np dot array of y. Okay, done. And we are going to the dot reshape of x comma, we have to convert this two-dimensional array to three-dimensional array. Okay, before feeding it to the model. Okay, x dot shape of 0 comma x dot shape of 1 comma 1. So that is also done now. Okay, now what I'm going to do is create a model is equals to, okay, before that we need to import the Keras, right? Keras dot layers import LSTM and dense layer and dropout. Okay, from Keras dot models import sequential. Okay, it's just importing. And yeah, let's start with the model creation. Model is equals to sequential. Now we are going to add the Keras layers. Model dot add LSTM long short term memory, and with the units as 50 nodes, and activation is equals to ReLU, and return sequences is equals to true. Okay, and the next one is input shape is equals to x dot shape of 1 comma 1. So here what we are doing is we are adding a LSTM layer with the 50 nodes, and where the activation is equals to ReLU and return sequence is equals to true. That means there is another going layer to be there to read this layer output as an input. Okay, and here input shape, we are defining the how this model takes the input data, the shape of the input data. Now we are adding model dot dropout of 0.2. So what exactly this dropout layer does is it will make sure that our model is not overfitting with the test data set. Okay, here 0.2 means in the sense 20% of the data will be added explicitly to avoid the overfitting of the model. Okay, then done. Next, model dot LSTM of, and here add 60 nodes, and activation is equals to ReLU, and there is going to be another layer which is return sequences is equals to true. Okay, and here model dot add of dropout of 0.3. Okay, and I'm just going to copy paste to save the time. Okay, here let's make it as 80 nodes and it as 0.4 and 120 nodes, finally 0.5, and here this is going to be a last node. Just going to remove this one. Okay, and finally we will be adding the output, that is model dot add of dense layer with units is equals to 1, because we need only one item as an output, right? So that's the reason units equals to 1. So our model is done, model created. Okay, model dot summary, this is going to give us the layers in our model. Okay, model name is sequential model, and first layer is LSTM layer. Okay, with the 50 nodes and dropout here, and LSTM second layer with the 60 nodes, and third layer with the 80 nodes, and fourth layer with the 120 nodes, and here the dense layer with the 1. Okay, with an output and dropout layers in the middle. Okay, and our model is created. Now we have to compile our model. Okay, model dot compile of optimizer is equals to Adam, and loss is equals to mean squared error. Okay, compile. Now let's fit our model. Let's fit model x comma y comma and epochs is equals to 1 and barbos is equals to 1. Okay, here what exactly we are doing is x, that is the input data set and output data set, and epochs is equals to 50. So 50 times it will be, the model will fit with the input data set versus output data set, and verbose is equals to 1. That means it will be just for the printing purpose. Okay, when the model is getting trained, let's just press enter. Okay, yeah, our model is started getting trained. Okay, and it would take a couple of minutes, so I will just wait for it to complete. So then once this model training is gets completed, and we will resume our video. Finally, our model got trained, and it took almost 12 to 13 minutes to get trained completely in this model. So now what we are going to do is we are going to predict the values based upon the test data set with the model. Okay, now let's check the test data. So it is having 100 rows of the data, right? So with this, we are going to predict this 100 days data. We need the last 100 days data in the test data set, right? Because based upon the last 100 days data only, we are going to predict the 1013 data. So what I'm going to do is I'm going to take the last 100 days data from the train data set, and I'm going to append it to here. Okay, concat and test train underscore data dot tail of 100 records, comma, this test data, and ignore index is equals to true. Okay, finally this is our test data. So we have 200 rows. Okay, now let's do the array slicing as we have done for the training data set. Now we are going to do the array slicing. Before there, I have to do the scaling of the test data. Test data scale is equals to scalar dot transform of this test data. Okay, scaling of our data is done. Now we are going to do the array slicing. That is also completed. Now let's check for one row. Yeah, so last 100 Bitcoin prices is there. Last 100 days Bitcoin prices are stored. So one set. Now we have to convert this x comma y to arrays. np dot array of x, np dot array of y. Okay, we have converted x comma y into the numpy arrays. So what we are going to do is x is equals to np dot reshape. We have to convert it into 3D array, right? And x comma x dot shape of 0, x dot shape of 1 and 1. Okay, now x is ready. Predict the values. Model dot predict of x. So our model has predicted the values. Now let's check the values, prediction values. So these are the predicted values. So what I'm going to do is let's convert them into normal values, because these values are scaled, right? These prices. Now we are going to use inverse transform of predicted values. Okay, so these are the predicted values. These are the original prices. So now we have predicted the values with the test data set, right? Now what I'm going to do is I'm going to predict the future prices of the stock, Bitcoin price. Okay, future Bitcoin price. So this is the most important topic and everybody is looking forward to it. So how we are going to predict the future Bitcoin price? Okay, so I'll just take an example of 5 days here. Okay, so if I want to predict the 6th day, let's take an example. I want to take the base price of last 5 days. So here in our example, we are taking it as 100 days as a base days. But let's take for this example, we are taking only the 5 days into the consideration. Okay, if I take this 5 days into the consideration, I'm going to predict the value for the 6th day. Suppose if I want to predict the value for the 7th day, and which are not in the data set, okay, test data set or training data set, what I'm going to do is I have to use the 2nd day to 6th day. So on the 6th day is going to be a predicted value. Okay, you are getting my point, right? To predict the n number of futures in the for the future days for this model, what we are going to do is we cannot do it in a single go. We have to do it in a repetitive process, because those predicted values will be a part of the predicting the future date. Okay, so that is what I'm doing here. And why is he having all the dates of last 100 days data. I'm just copying this into a one array m. Okay, copying into a dummy array m, and here what I'm doing is just taking z, okay, for I, and here I'm going to add one more, future days equals to 1, okay, I in range of um, base days anyways, and length of m plus future days, okay, it has to repeat for n number of times based on whatever the future days which we are going to predict the values. Here I'm going to predict the next day value, okay, and what I'm going to say here is m is equals to m dot reshape of minus 1 comma 1, and m dot reshape, right? Now we have to take the one intermediate data set, enter of minus base test last 100 days data colon 0 and 0, and closing this one, okay, and enter is equals to np dot array of enter, and enter is equals to, we have to convert it to a two-dimensional array, right? np dot reshape of enter comma shape of 0, enter dot shape of 1 comma 1, okay, and we have to pass it to the model dot predict of this intermediate value, okay. So once we predict this value, what we are going to do is we have to add it to the z is equals to z dot np dot append of this predicted value z comma predicted value, okay. Okay, it's predicted the value. Let's check z is equals to np dot array of z, and it will be a scale value, right? We have to convert into normal value, scalar dot inverse transform of z dot reshape of minus 1 comma 1, okay. Now let's see the value of z. Here should be m, okay. Okay, the predicted value should be 35,439, okay. If I want to predict for the next 5 days, okay, it's predicting the values, it's getting the values, and I don't know, somewhere went wrong. Okay, I got it. We have to add it to append to m, right? M is equals to np dot append of m comma predicted values, okay. Predicting this next, okay, these are the next 5 days. If you see here, our model is predicting that there would be a downtrend in the Bitcoin prices. Here we can predict values for the next 30 days also, okay. It's predicting, yeah. So I think our model is predicting that Bitcoin price would go down again, okay. It's seeing that, it's anticipating a downfall of the Bitcoin prices, okay. But in actually today is the date is 6th of December, but the Bitcoin price is almost 44k USD dollars, okay. So that's the reason I'm telling you. So this whatever this machine learning model that we are doing, it is only for the educational purpose. Don't take it into the consideration of the investment advice, okay. Now we have done this one. Let's build the web application as you have seen in the earlier part of this video. So I'm just saving this model now. Model dot save of Bitcoin price prediction model dot Keras, okay. Finally our model has been saved. Now let's jump into the Visual Studio. Okay, let me create a app.py, okay. Let's import the necessary libraries first. Import numpy as np, pandas as pd, and for data yfinance yf, and import keras dot models, okay. Import keras dot load model option, okay. And what else we need? pandas numpy by finance and from scale learn dot preprocessing import min max scalar. Okay, now again we would need, I think that should be fine. Let's load the model first. Model, go to load model of, okay, here model. Okay, here is the model. Copy path and I'm just, okay, okay, and let's import streamlit. Okay, and okay, st dot header of Bitcoin price prediction model. Okay, let's save it and run it. There is a typo, it's going to correct it. Okay, should be good. Now run the app. Okay, as streamlit run app.py. This is a command to run the streamlit app as a web application. Okay, if you press enter, browser will pop up. Okay, and this is going to be, yeah, our web application Bitcoin price prediction model. And closing this one. Okay, now we have the model. First let's download the data. Okay, data is equals to yf dot download btc-usd comma 2015 01 201 comma 2023 011 30. Okay, and put it as a pd dot data frame of this one. Okay, and data dot reset index. Okay, and place is equals to true. I don't think it is required. Home data is equals to, okay, st dot write of this data and st dot subheader Bitcoin price data. Okay, let's save it and coming here, click on always run Bitcoin price data. It's empty. Okay, let it download. Is it downloading? The download. Okay, just have to use BTS. Okay, yeah, here is the data. Okay, and now I'm going to draw the chart. Okay, uh, data, let's copy some of the code from here. Okay, and if you don't have to do anything again, this one, copy it here. Okay, and once we have this one, we should be having data, right? Okay, st dot line chart of this data. Let's see what it is going to be. Okay, this is what the line chart is looking. It's complete Bitcoin price from since 2015 1 to till the date. Okay, now what we are going to do is, okay, Bitcoin price data and st dot subheader Bitcoin line chart. Okay, price data and Bitcoin line chart. Next what we are going to do is, we need the sklearn, right? Pre-processing. I need to create that test data set and train data set. Okay, data. Train data is equals to train data is equals to data of minus 100 days. Okay, and test data is equals to, here I'm just directly going to take the last 200 days data. Okay, anyways we need that for that, right? And scaling the data. Okay, for scaling what we are going to do is scalar is equals to min max scalar and feature range is equals to 0 comma 1, and train data is equals to scalar dot fit transform of this train data underscore scale. Okay, and test data underscore scale is equals to scalar dot transform of test data. Okay, and I'm going to copy the few of the array slicing and all that stuff. Okay, uh, here I'm going to copy paste this one. Okay, here we have the base days is equals to, sorry, base underscore days is equals to 100 days, because that is how our model got trained. np array on this data, just going to copy this one, also copy. Okay, this is train, right? So we need to just change it to test scale data. Okay, once you guys have this data, you guys need to predict the data. Copy the things from here. Okay, prediction. Okay, and converting this one, and predictions is equals to prediction dot array shape of minus 1 comma 1. Okay, and the next thing is y is we holding the data, right? So y is equals to scalar dot inverse transform of, and y dot reshape of minus 1 comma 1. Okay, so once we are done with that array x y, and we have to draw a chart, right? And here predictions is equals to ed dot data frame of predictions, and columns is equals to predicted price. Okay, and same way we have to do it for the original price as well. Original price is equals to y, and here it is y. Yes, I'll just change y. Yes, okay, because that we need that y data, right? And so once we have that, let's combine this chart data into a chart data is equals to pd dot concatenation of predictions comma yes. Okay, um, comma access is equals to 0. Okay, then st dot line chart of chart data. Let's see here. Okay, something went wrong. Predicted price, original price. Okay, and st dot sub header of predicted versus original prices. Okay, so what I have written is, here I am just sub editor, and here we are predicting the values, and I'm just inversing the transform to the original values, and then I'm reshaping this one. Similar way, original prices are stored in y array, right? Numpy array. I'm just scaling that one to the actual values, and here I have created a two data frames, one with the predicted price and one with the original price, and I'm concatenated both of them with access is equals to 1, and here the chart data is this one. Before going here, prices, and I am going to add one more thing here. Prices. Okay, and st dot write of this chart data. Okay, let's see here now. Yeah, here is the Bitcoin price prediction model with the base price. Okay, and here is the line chart, and here is the predicted prices versus the original prices. Okay, and predicted versus original prices chart. Okay, somewhere it is touching, there is slight difference here and there. Okay, the thick line is the original price and the light line is the predicted prices. Okay, once we have done, we have to predict the future prices, right? Now here future days is equals to future days equals to 5 days. Okay, I'm just going to copy paste from here. uh, yeah, it's complete part actually. I'm going to predict just the next 5 days data, and copy paste it here, and here st dot line chart of z. Okay, just going to see how it is looking. Yeah, and here I'm going to write st dot subheader of um, future days Bitcoin price predicted. Okay, future days Bitcoin price. Let's write something like this. Okay, here is the final web application looks like Bitcoin price prediction model. Okay, here is the data, Bitcoin base price data, which we have downloaded from the Yahoo Finance from 2015 January 1st to almost November 29th, right? Yeah, till November 29th we have taken the data from the Yahoo Finance. Okay, now the next thing is a Bitcoin line chart. This line chart has been drawn based upon the data which is showing in the above here, right? So based upon this data we have drawn a line chart here. And the next thing is our model had predicted the last 100 days Bitcoin prices, and we are comparing that prices, predicted prices, with the original prices of the Bitcoin. Okay, here is the predicted price and versus the original price, and if you see here there is a slight discrepancies here and there. Okay, and finally here is the chart for the above data, predicted versus the original prices chart for the last 100 days data. And here is the most important part, predicted the future days Bitcoin price. So here we have predicted the next 5 days from, we have the data till November 29th, right? So next 5 days mean the sense November 30th to December 4th. So whatever the Bitcoin price is going to be, so we have predicted that price. Okay, by using this machine learning model that we have developed here. If you like the content in this video, please do like and subscribe to our channel. Thank you all. Thanks for watching this video.